Hey, time for respiratory number 4. Starting up with the bronchioles. So we were just doing bronchi last time, and bronchioles are going to branch off bronchi. Pretty much by the time we get to bronchioles, we've done so much branching that our tubes are very small. Their diameter is less than a millimeter. And at this point, they lack cartilage, although they do have a significant amount of smooth muscle now, which is going to be important because it's going to let us constrict and dilate the bronchioles, which lets us adjust the directionality of airflow. All right, bronchioles branch like crazy too. Big bronchioles beget medium bronchioles, which beget smaller ones, and eventually we have the last two bronchioles, terminal and respiratory bronchioles. Respiratory bronchioles are designated by the presence of some sparse random alveoli. All right, respiratory bronchioles are the beginning of the exchange zone, the respiratory zone. Terminal bronchioles, on the other hand, are the last bronchioles, hence terminal, where alveoli are not yet present. Now notice, of course, respiratory bronchioles give rise to an alveolar duct, which then terminates into a bundle of alveoli known as an alveolar sac. All right, some questions for you to do here. Enjoy. Let's talk about respiratory bronchioles. Here one is right up here. Here's one right here. Check out the relative paucity of alveoli. So we're doing some gas exchange here, but not a crazy amount. Still got simple cuboidal epithelium in between, so it's kind of thick in between. And then we'll give rise to alveolar ducts. Here's an alveolar duct down here. Now we have a tube, a passageway, a throughway, made of basically side-by-side alveoli. Then that terminates in just a big dead-end cluster of alveoli, and this is known as an alveolar sac. By the way, the word alveolus means grape. Use your imaginations, and maybe you can think of a bunch of grapes here. All right, on this picture, this is kind of a lab review. You should be able to identify for me terminal bronchiole, respiratory bronchiole, alveoli, and alveolar duct. Good luck. Show me what you got. All right, alveoli, they are the sites of exchange. As such, they're going to need simple squamous epithelium because exchange is mediated by diffusion, and the enemy of diffusion has always been, will always be distance. You have about 300 million alveoli in your lungs. They are cobweb with pulmonary capillaries because, of course, exchange is a two-way street. Got to have something given and something getting in any form of exchange. And also, what else is going on? Well, our alveoli are covered by elastic fibers as well. What this does is it facilitates the expiratory process. So you breathe in, stretch your lungs, takes muscular action to do that, diaphragm, external intercostals, etc. But the expiration process is much more passive. It can be accomplished solely with the recoil of the elastic fibers around the lungs, and we do see them down here, by the way. Oh yeah, smoking kills these elastic fibers, making breathing out harder for you, which is bad, definitely. All right, so what we've done is we've sliced open some alveoli here. So look at the inside of alveoli, little spherical alveolus. This is like a hemisphere right here. Alveoli are linked to one another by alveolar pores so that they can have a balanced pressure. The majority of the cells in the alveoli are the simple squamous epithelial cells. They are known as type 1 alveolar cells. They are the sites of gas exchange. There are other cells present. There are alveolar macrophages, aka dust cells, because obviously they eat a lot of dust. There are also type 2 alveolar cells. Type 2 alveolar cells produce a chemical called surfactant, S-U-R-F-A-C-T-A-N-T. We'll come back to him later, all right? So lodge that somewhere in your brain, surfactant. So you say, oh yeah, he mentioned that later on. Okay, if we zoom in on the spot where a type 1 alveolar cell, which is right here, abuts a pulmonary capillary cell, this is the place where exchange happens. This is known as the respiratory membrane. CO2, of course, diffuses from its high pressure zone in the blood to its low pressure zone in the alveolar air. Oxygen will diffuse from its high pressure zone in the alveolar air to its low pressure zone in the blood. And they do so across the respiratory membrane, which is a pair of simple squamous epithelia, 1, 2, plus a little bit of connective tissue in between. Okay, awesome. Kind of done with the lung, but not quite. We got to do the covering of the lung. The lung is covered by the pleurae. Each lung, rather, is covered by pleurae, a double-layered serosal membrane. There is an inner visceral pleura, which basically forms the surface of the lung itself. Then there is an outer parietal pleura, which is going to form primarily the thoracic wall, but also be found on the surface of the diaphragm, around the mediastinum as well. In between these two pleural membranes is a small potential space called the pleural cavity, which will contain pleural fluid. So, right-hand picture, identify the purple and the blue lines for me. I'll give you a minute to do that. And now, so you got this pleural membrane, right? Here's a diagram of the lung, right there. And there's the pleural membranes around it. Notice they are connected right here. Yeah, you see that right there as well. Right there as well. And visceral on the inside, parietal on the outside, pleural fluid in between. Okay, we've met this situation before. We saw this in the heart with the pericardium. Recall that the primary function there was the reduction of friction as the heart beats. Same job here. We want to reduce friction. We want to lubricate so we don't have sliding and rubbing as we take a big deep breath in and out. Okay, there's another function too. Get a glass table, a miniature glass table, judging by my picture here. Put a drinking glass on top of it, but wet the table, and stick the drinking glass on top of it, and then try and lift the drinking glass up. It'll be really hard to do. Water will stick things together. Water sticks glass to glass, for example. Water also sticks the two pleural membranes together. The two pleural membranes are going to be stuck together by pleural fluid. This is hugely important because look at the diaphragm here. Remember, when the diaphragm contracts, it flattens out, it goes down. The diaphragm is directly connected to the parietal pleura, the blue line there. So when the parietal pleura goes down, it drags the visceral pleura with it because of the pleural fluid. And what that does is it lengthens the lungs. So the movement of the diaphragm yields the enlargement, the increasing of the volume of the lungs. All right. So we'll quit here, pick up with pressures next time. Adios.